In this video, we're going to implement a simple predictive model for housing price prediction using PyTorch. So, first of all, we import our required libraries. We have Torch, Matplotlib, Pandas, NumPy, and then sklearn for train test split, and then standard scaler. So we'll run the imports first. Now we'll start by loading our dataset using Pandas. We read a simple CSV file that contains the area of a house and its corresponding price. So this is a minimal dataset just to demonstrate the fundamentals of linear regression. Now you can see our data here where we have area and then price. But before we dive into modeling, we explore the data using this particular function here. So this function gives us basic statistics like min and max. Then we plot the data visually to inspect the relationship between area and then the price. So if you see, or if you plot this data, you see that we have a clear positive trend. So larger home tends to cost more and more price. So next we prepare our data. We separate the features first and then the target variable, and then we convert them to NumPy arrays here. Now we come on to normalization part. So what normalization does is it scales both input and output so that they have a mean of 0 and a standard deviation of 1. So why this normalization is essential? Because this helps the model learn faster and perform better, especially when feature values are on very different scales. As we see up here, the scale of area and price are not at the same. Hence, we need to perform some form of normalization or standardization. To do this, we're going to run this. I think we've missed a library here, so let's import here. Import NumPy as NP. Okay, the standardization part is also complete. Now we split our data set into training and validation part. So we use 80% of our data for training and then keep 20% aside for validation. So after that we convert our NumPy arrays into PyTorch tensors. So that is the format the PyTorch models require. Let's run this again. In another part, we define our model here. So this is a simple linear regression model using PyTorch n.linear function. Since we have one input and one output, so here is the input dimension and then here is the output dimension. Then we define our loss function, which we're going to use as mean squared error loss, and our optimizer will be stochastic gradient descent. These controls how our model learns from errors and updates itself. So we'll run these hyperparameters at first. So now comes the training loop. Here in each epoch we do a forward pass to get our predictions. We calculate the loss and then we perform a backward pass to compute gradients and then update the model weights. So we also print the loss after every 50 epoch to keep track of how well we're doing here. So this is our training loop. Also, I'd like to add these two parameters here. So number of epochs, let's say we'll keep it 100, and then the losses will be tracked for each epoch. Now we run this and then we see that previously our loss at 50th epoch was 0.2603, and then the loss at 100th epoch was 0.0437. What I'm going to do is I'm going to remove this and I'm going to print it for every epoch so that we see a decreasing trend of loss here, and then we understand that the model is learning something. Let me rerun the upper part again where we have initialized our model. Then when we run this lower part, we can see that the loss has actually started from 0.1658. Gradually it has decreased to 0.09, 0.08, and then it has eventually come down to 0.0135. So we see a decreasing trend in the loss here. So after training, we can also plot the loss across epochs, a decreasing loss curve that we've analyzed and then seen here is a good sign. It shows that the model is learning to reduce the error between the predicted and the actual price. Now we'll make some real world predictions. So we have defined a function that takes the housing area as input, scales it, and then scales it using the same scalar we used earlier, and then pass it through the model. So the model gives us the scaled output, and which we then inverse transform to get the actual predicted price. So finally we evaluate our model. Example, we have an input area of 3750. The model predicts a price based on what it has learned, and then here's the output. The price shown is $689,000, 581. So this is a reasonably accurate prediction given our simple data set. So this is the complete implementation of a very simple prediction model where we've used just one feature and then predicted the price based on that particular feature here. So in the upcoming videos, we'll try to include multiple features and see how we proceed ahead with our predictions. So until then, stay tuned. If you have any problem implementing this, do comment down below and I'll try to help you out.